Good day and welcome to lesson number 9, using graphic organizers. For this lesson, we have the following objectives. At the end of this lesson, you will be able to define graphic organizers, distinguish the different kinds of graphic organizers, determine the use of the different kinds of graphic organizers, and present data using graphic organizers. So what are graphic organizers? According to Inspiration Software in 2018, graphic organizers are visual displays which establish and demonstrate relationships between facts, concepts, and ideas. And there are 4 common types of graphic organizers. We have diagrams, or more commonly or specifically, we have Venn diagrams. We have charts, specifically the pie chart. We have graphs, which have 2 general types, the bar and the line graphs. And lastly, we have webs and maps, specifically concept maps and story webs. So let's discuss these common types of graphic organizers, how they are used, and how they are constructed. So we begin with diagrams, specifically with Venn diagrams. So these are used in order to establish the similarities and differences between 2 or more variables. And we construct these diagrams by drawing 2 or more overlapping shapes, and most of the time we use circles. As you can see in the examples, there are 2 overlapping circles, and what's found inside the overlapping space would be the similarities between birds and bats, and what we find in the non-overlapping space would be the unique characteristics or the differences between birds and bats. Now you might ask, can we assign more than 2 variables to a Venn diagram? Of course. Again, you can use 2 or more overlapping shapes. So if you have 4 or 3 variables, then you can still use 4 overlapping circles or 4 overlapping shapes if you want to use other polygons. So moving on, we have charts, and specifically pie charts. Pie charts are used to show the individual breakdown of the parts of the whole. And keep in mind that the data presented using pie charts are dependent data. What does dependent data mean? It means that an increase in one data will mean the decrease in another. So how are pie charts constructed? These are constructed by cutting up a circle into segments or slices. Now in the example, you can see that 3 circles are cut up into different slices, and by showing dependent data, it means that if one segment or one slice increases in size, that would mean that 1 or more slices might decrease in size as well. So that is why it is dependent data, because if one slice increases, another size decreases. Okay, moving on. We have the first type of graph, or the bar graph. Bar graphs are generally used in order to compare numbers between different categories or different components. And how do we compare those components? We compare them by assigning the x-axis for the components and the y-axis for the numerical scale. If you can see in the example, we have one general group, which would be the nicest fruit, and the x-axis contains the different categories or components. We have apples, oranges, bananas, kiwi fruit, blueberry, and grapes. And to the y-axis, we have assigned the numerical scale, 5 until 40. Now, the data needed in bar graphs are independent. What does that mean? If one category increases in number, it does not mean that the rest of the numbers will decrease. So it means that one value is isolated from the rest. This would be good if you are conducting a survey. Okay, so these are constructed by the use of bars, axes, and numbers. The second type of graph is the line graph, and these are usually used to show dependent data. And this dependent data is shown to trend over time. So what does that imply? It implies that we have to depict a point value for each category and show whether there has been an increase or decrease in those values over a period of time. In the example, you can see that yes, there are still categories as found in the x-axis, the days of the week, and a numerical scale to the left or in the y-axis from 0 until 30. But instead of assigning bars, we have assigned lines to connect the dots. What do these lines imply? These lines imply the dependency of the data across the entire graph, which means if you have a value of 25 on Sunday and a value of 15 on Monday, this means that there are less push-ups made on a Monday as compared to Sunday. That's why the data here is dependent. So how do we construct line graphs? These are constructed with the use of lines instead of bars. Still, we have axes and we still have the numerical scale. Okay, on to the last one. We have webs and maps, and we begin with webs. So, what are webs? Webs show the relationships of two or more events or concepts found in a text. Make sure to keep in mind that the data found or the information found in your webs would be dependent data. Again, this means that one variable affects the other. In this case, the effect is causality. What does causality mean? It means that one concept causes the existence of another. How do we create webs? We use shapes and we use arrows. The arrows are going to depict the relationship, whether the relationship is going inward or it is going outward. In the example provided, the relationship depicted is inward. What does that mean? It means that the factors you can find on the outside, such as institutional factors, health beliefs factors, individual factors, and socio-economic and demographic factors, cause the existence of the central idea. When we are talking about factors, then it is good that we show or depict the webs to have an inward direction. But when the central idea causes the existence of the different results, then the arrows should go from the central idea going out. This means that the central idea causes the existence of the realities or the results found in the shapes outside the central concept. Lastly, we have maps. So maps are not your geographical maps. Instead, these are what we call concept maps. So maps are general organizers that shows still a central idea, but instead of causality, we simply attach its corresponding characteristics. So maps can be used to show a hierarchy of the relationships with the most important concepts or the main concepts found at the top instead of at the center, and then the least important concepts or even its subcomponents down below. How are concept maps created? Well, they can take many different shapes and can be used to show any type of relationship that can be labeled. But the most important thing to remember is that concept maps also contain shapes, but instead of arrows, they use lines. Okay, as you can see in the example given. Now, one very common type of concept map would be an organizational chart or an organizational map in your offices or in schools, wherein you show how an organization is broken down into its different components, starting with the highest position on top, usually the CEO, the principal, the COO, whatnot, and then broken down into its components per department, down to the grassroots. So that's how maps are used in daily life, or those are common examples of maps. So in this lesson, we have broken down the different kinds of visual and graphic organizers. We have defined those graphic organizers. We have distinguished their different functions. We have also determined how they are going to be constructed and used to present your data. And hopefully, because of the knowledge that you already possess regarding these different graphic organizers, you may be able to present your own data using one or even all of the graphic organizers that we have discussed. And that being said, I believe that concludes our lesson for today. Again, this is Sir Dardar wishing everyone a great day ahead. Class dismissed.